Hello, algebra students. Mr. Lawrence here, and we're going to do a brief flip lesson. And remember, I'm not going to be in class tomorrow. I expect you to be on your best behavior. I don't want to hear from any of you about tomorrow. I don't want to hear about anything bad from the sub about you. You know what I'm trying to say. Sorry, I was distracted there momentarily. All right, well, we've just finished the joy of graphing, and hopefully you are an expert grapher by now. And today in class, we're graphing parallel and perpendicular lines, and hopefully you recognize that. Oh no, my airliner's not on. There we go. Right? Okay, here we go. Parallel lines. That does not mean 11. That is the symbol for parallel. Okay, parallel lines have the same slope. So if you know the slope of one line, and you know another line is parallel to it, they must have the same slope. And perpendicular, there's a symbol for perpendicular lines. Their slopes are negative reciprocals, which means you flip the fraction and change the sign. All right, so just real quick, just to review before we get on to the new material, I'm going to graph this blue equation, and I'm going to get y-intercept of -4, right? I'm going to run 3, rise 3, run 2, rise 3, run 2. That doesn't look right. Looks like I only ran 1. So I'm going to have to erase him. And I'm going to rise 1, 2, 3 and run 2. Okay. And now some of you are saying, hey, I got to get my third point in. You only need to show 2 points on any line. The third point just helps us draw a prettier line, make it a little straighter, reduce the amount of human error. But it doesn't actually do anything for the line. Okay, so there's the blue line. Now I'm going to graph the red line, and it has a slope of -2/3. It kind of looks like 3/2, but it's flipped and the sign is changed. That's a negative reciprocal. You see that? You have 3/2 here, but here you have the negative of 2/3. That's a negative reciprocal. I'm expecting this to produce a perpendicular line. Let's see, I'm going to do a y-intercept of 1. And I'm going to go run 2 and run, I'm going to rise -2 and run 1, 2, 3. Now, Dylan, be careful. Make sure you don't rise -2 and then run -2, right? Like we talked about in class today. You're a smart guy. I know you won't do that anymore. So we're going to rise -2 and run +3. Or I could go back to the y-intercept and rise +2 and run 1, 2, -3. All right, so I'm going to go ahead and draw that line. Rise 2, 1, 2, 3. And there we go. And give me a moment here. So there we have a red line, and it does indeed look like it's perpendicular. Remember, that means it makes 4 right angles here when they cross. Okay. Now I have this green line to do, and it has a slope of 3/2. So I'm expecting it to be parallel to the blue line, and it has a y-intercept of 5. So I'm going to go 1, 2, 3, 4, 5. I'm going to rise 1, 2, 3 and run 2. And I'm going to go down 1, 2, 3 and back 2. Down 1, 2, 3 and back 2. And watch this. Since it is parallel, watch what will happen. Control D. I clone that line, and when I clone that line, it makes a parallel line. And watch. Uh-oh, something's wrong. Did I count wrong on one of my slopes? I'll bet you I did, because my points aren't matching up. Let me erase these two. Well, let me redo them. Go back to the y-intercept and go down 1, 2. And then, oh, excuse me, down 1, 2, 3, and then 1, 2. Yep, I sure did. I counted wrong on my slope. I went down 4 and over 2. So if I go down 1, 2, 3, and back 2, look at that. I hit the line perfectly. See, anybody can make mistakes on this, but if you understand what's supposed to happen, you can eliminate some of your mistakes. Okay? Think about what you're doing. Don't just be an automaton imitating exactly what I do. I mean, sometimes you might have to fake it till you make it kind of thing, but pay attention to what you're doing and try to make the connections. All right, now, today what we're going to do is a review of something, but we're going to apply it to this parallel perpendicular idea. We're going to be given an equation, y = 2x - 5. We're not even going to graph that equation. But I am going to pay attention that my slope is 2, right? Or 2 over 1. I need the equation of a line parallel to it, but it has to go through the point 4, 8. Well, I'm going to mention that that's an x-coordinate and that's a y-coordinate. And since my slope is 2, the slope of the line parallel to it, that's not M11, that's parallel, slope parallel, it will also be 2. Now, if I work from this equation, y equals mx plus b, you should remember doing this. I'm going to plug my slope in for m. My x-coordinate is going to be 4 from here. My y-coordinate is going to be 8. And I am going to solve for b. This should look really familiar. So when I do that, I'm going to get 8 equals 8. 2 times 4 is 8, plus b. When I get b alone, I'm going to find out that b equals 0. So the equation of the line parallel to the black line, and it passes through the point 4, 8, would be y equals 2x plus 0, or better yet, y equals 2x. This would be the best answer because it's the simplest. This should look almost exactly like what we were doing just a few days ago. We found the slope, we found the y, we found an x value, a y value, we plugged them into the equation y equals mx plus b, and we solved for b, and then we can write our equation. All right, let's try it with the red equation. So my slope of the original line was 2, right? My perpendicular slope is going to be negative 1/2. I have to consider 2 as a fraction, flip the fraction, right, and change the sign. So now I go to the equation y equals mx plus b. I know I have an x-coordinate and a y-coordinate. I'm going to substitute in values for everything except for b. I'm going to solve for b. So I put 8 in there, and put negative 1/2 there, and put 4 there. I'm going to simplify my equation. The right-hand side, negative 1/2 times 4 would be negative 2 plus b. I'll add 2 to both sides, and I'll get that b equals 10. So now that I know the slope and the y-intercept, my equation is y equals the slope x plus 10. And there you go. And if you took the time to graph them, you would see that the red equation is perpendicular to both the black equation and the blue equation. And the blue and black equations are parallel to each other. All right, let's do one more example, and then you get a chance to practice this in class tomorrow. All right, this equation is in standard form. And if you've been paying attention, I demonstrated how you can find the slope. The slope will be a over b, and then I'll change the sign, right? So there's your slope. So what's the slope of the line parallel to it? Well, it's also going to be 3/4. I have an x-coordinate over here and a y-coordinate over there. I'm going to use the equation y equals mx plus b. I'm going to fill in everything but b. See, y is 2. Slope is 3/4. The x-coordinate is 12. Put that over 1. I'm going to get 2 equals 4 is going to go into 12 3 times. Looks like I'm going to get a 9 plus b. Subtract 9 from both sides. And I'm going to get negative 7 equals b. My parallel equation will end up equaling y equals 3/4 x minus 7. And there you go. Coming down to the red part of the problem, problem B, I need the equation perpendicular going through that same point? Well, the original slope was 3/4, right? Let me just go up and double check. Yep, 3/4. The perpendicular slope would be a negative of 4/3. Flip the fraction, change the sign. Again, I've got an x coordinate and a y coordinate. Y equals mx plus b. Gonna fill in for m, x, and y. So I'll get 2, negative 4/3, there's 12 for 1. And when I do that, I'll get 2 equals, 3 is going to go into 12 4 times. Looks like I'm going to get negative 16 plus b. Add 16 to both sides. And I'm going to get 18 equals b. Therefore, my new equation is y equals negative 4/3 x plus 18. And it's just that simple. Remember, you need to find the slope of the original equation. For the parallel line, you use the same slope. For the perpendicular line, you use the negative reciprocal. And then you take the x coordinate and the y coordinate of the point given to you. Use those coordinates, the slope, to help you find the y-intercept. Then you can write your equation. All right, that's it. Like I said, you'll get a chance to practice this in class tomorrow. Mr. Lawrence signing off. Good night, everybody.